Okay, so I'm going to solve this equation. 3 sine 2 theta equals 2 sine theta. Okay, so we've got a double angle here. You either learn and know what the expression of sine 2 theta is. If you don't, you can actually derive it by using the formulas on page 4 from the compound angles. If I take the top line here, sine of A plus B is sine A cos B plus cos A sine B. So taking that from page 4, as I say, sine of A plus B is sine A cos B plus cos A sine B. Okay, and then if I put A and B both equal to theta, look at the sine of theta plus theta is sine theta cos theta plus cos theta sine theta. So that's the sine of 2 theta is 2 sine theta cos theta. So in this equation I replace the sine 2 theta with that. Expand. And then you've got to be very careful at this point here. And what some people do, and it's wrong, you cannot cancel the sine thetas off. If you cancel it off, you'll lose solutions. You need to take it all into one side and factorize it. So that's 6 sine theta cos theta minus 2 sine theta equals 0. Then the common factor is 2 sine theta. So that's 3 cos theta minus 1 equals 0. So either 2 sine theta equals 0 or 3 cos theta minus 1 is equal to 0. So this one gives me sine theta equals 0, and this one gives me cos of theta equals 1/3. So just sketching the graph to get the solutions. Measure them out. Okay, so it's minus 1, 1. So that's the sine graph. Where is that equal to 0? It's equal to 0 there, there and there. So theta is 0, 180, 360. And then if cos theta is 1/3, again drawing the cos graph. Cos theta is there, 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 and there. And then the 1/3, put the line across, that's at 1/3, so the value there, and the value there. So press shift cos of 1/3 to get the first one. So 70.5, so that there is 70.5, so theta is 70.5, and the other one then is 360 minus 70.5. It's 289.5. Okay, part B. Says find all the values of x in the range satisfying this equation. Okay, now then, if we look at that equation, we note this. There's no squares there. Okay, so I'm not able to use the identity of sine squared plus cos squared equals 1. So on this paper, this is an example of the harmonic equation because both cos and sine are linear. So I have to rewrite the left hand side in the form of r sine or r cos of theta plus alpha, or x plus alpha in this case. And because there's a plus sign, I can use the plus with the r sine x plus alpha. So if I rewrite the left hand side as r sine of x plus alpha, and then to expand sine of x plus alpha, again I'm on page 4, is there for me sine of a plus b, sine a cos b plus cos a sine b. So that'll be r sine x cos alpha plus, and then multiplying with the r as well, r cos x sine alpha. So I compare coefficients of cos x, so that's 4 equals, like this cos x, that's r sine alpha, and sine x, that's 3 equals, and sine x is r cos alpha. Okay, so to find alpha I divide. So I divide, and make sure when I divide I have the sine alpha on top, so that's r sine alpha over r cos alpha. That's 4 over 3. So the r's cancel off. Sine over cos is tan. And then to find tan, shift tan of 4/3. And that's 53.1 degrees. And then if I square and add, and I got r squared sine squared alpha plus r squared cos squared alpha is 4 squared plus 3 squared. So factorize that. (16 plus 9). Sine squared plus cos squared is 1, so it's just r squared on the left hand side. 16 and 9 is 25. So r is the square root of 25, which is 5. So there's the value of r and alpha. So I can rewrite the 4 cos x plus 3 sin x is the same as r sine of x plus 53.1. And now I can solve that equal to 2, so I rewrite the left hand side. So r is 5, sorry, so 5 is there, so I got 5 sine of x plus 53.1 is equal to 2. Take the 5 over, so it's the sine of x plus 53.1 is equal to 2/5. So x plus 53.1 is sine to the minus 1 of 2/5. I want all the values from 0 to 360. And then when I get my answers for sine to minus 1 and 2/5, I can be subtracting 53.1 away from them. So although I want my answers from 0 to 360, I need to draw the graph one quadrant further, so I need to draw up to 450. Okay, so let's snap those off. It's 0, 90, 270, 360, 450. Okay, so plus shift sine of 2/5. That's 23.6. So this angle is 23.6. So to get this angle is 180 minus 23.6. And the one that goes past is 360 plus 23.6. So that's what x plus 53.1 is, and then each of these I'm going to have to subtract 53.1 away, so let's just evaluate them first. 180 take away 23.6, that's 156.4, that's 383.6. So x is, right, so this first one, 23.6 take away 53.1, that's negative, so that's out of the range, so that one is gone. Second one is 156.4 take away 53.1, and the third one 383.6 take away 53.1. So that's 103.3. and 330.5. I say you've got to be careful here with that. As I say, if you're going to end up subtracting from all the angles, you're going to have to go past the 360 by 90. And the question, if I was subtracting here, I'd have to bring it back 90 degrees just to check that.